For more than 40 years, a placard inside the museum at Xi'an told visitors something that sounded almost too advanced to be real: that the bronze swords buried alongside China's terracotta army had been coated in a form of chrome plating, a preservation technology so far ahead of its time that Europe wouldn't rediscover it for another 2,000 years. It was one of the most repeated facts about the entire site, cited in documentaries, textbooks, and tour guides across the world. Then, a team of scientists ran the actual chemistry, using instruments the original researchers never had access to, and the number came back wrong. Not slightly off, completely backward. The chromium wasn't a coating at all, and it had nothing to do with why those blades still gleam after 2,000 years underground. That single correction is only the beginning of what a new generation of scanning technology has actually revealed about Qin Shi Huang's buried army. And some of the real answers turn out to be stranger and more human than the myth they replaced. Before getting into what the scans found, it's worth being clear about what this site actually is and who's doing the research. Because the terracotta army attracts almost as much exaggerated content online as it does real archaeology. The army was discovered by accident in 1974 when farmers digging a well near Xi'an in Shanxi province struck fragments of buried clay. What they'd found was part of the mausoleum complex of Qin Shi Huang, who unified China's warring states into a single empire in 221 BC and ruled as its first emperor until his death in 210 BC. Buried around his tomb, spread across 3 massive excavated pits, are an estimated 7,000 life-size terracotta soldiers, along with horses, chariots, and thousands of real bronze weapons. The research referenced here comes primarily from a long-running collaboration called Imperial Logistics, the making of the Terracotta Army, led by archaeologists including Professor Marcos Martinon-Torres, Professor Andrew Bevan, and Dr. Xuzhen Li, working across University College London and the Emperor Qin Shi Huang's Mausoleum Site Museum in China, with findings published in peer-reviewed journals including Scientific Reports and Nature's Heritage Science publications. This isn't speculative content pulled from documentary reenactments. It's more than a decade of published chemical and statistical analysis running on real excavated material. Let's start with the chromium myth, because it's the clearest example of how advanced scanning technology can actually overturn a decades-old assumption rather than just confirming it. Since the 1970s, researchers had noticed something odd. A small number of the bronze weapons recovered from the pits, swords, lances, and halberds in particular, had survived 2,000 years underground, looking almost pristine, with sharp, unblemished edges that shouldn't have been possible after 2 millennia of burial. Chemical testing detected chromium on the surface of many of these weapons, and researchers reasonably concluded that Qin dynasty metalworkers must have developed an early form of chromate conversion coating, the same basic chemistry, functionally, behind modern chrome plating, centuries before anyone else on Earth. It became one of the most celebrated claims about the site's craftsmanship, presented as proof of a lost, sophisticated preservation technology. To actually test that claim properly, the UCL-led research team analyzed 464 separate bronze weapons and fittings, using 2 modern, non-destructive instruments: portable X-ray fluorescence, which reveals the elemental composition of a surface without damaging it, and scanning electron microscopy, paired with energy-dispersive X-ray spectroscopy, which maps out both the physical structure and chemical makeup of a material at extremely high resolution. Because the sample size was so much larger than anything used in the original 1970s and 1980s research, the team could finally check where the chromium actually appeared across hundreds of individual objects, rather than relying on a handful of isolated readings. The pattern that emerged was decisive. Chromium consistently showed up on weapon parts that had once been directly connected to wooden or bamboo components, spear shafts, sword grips, and other organic fittings that had long since decayed away in the burial soil. It was largely absent from the best-preserved, sharpest bronze surfaces, the exact places you'd expect a deliberate anti-corrosion coating to matter most. Further testing on the black lacquer used to coat and decorate wooden and organic elements throughout the mausoleum found something telling: that lacquer itself was extremely rich in chromium. The scans had found the real source. As the organic components decayed over 2,000 years underground, chromium-rich lacquer residue migrated onto the adjacent bronze surfaces through simple chemical contact, an accidental byproduct of decoration, not a deliberate coating applied for preservation. It's worth pausing on how the team actually proved the direction of that contamination. The lacquer was the source isn't the kind of claim you can just assert. It has to be demonstrated. Researchers ran controlled experiments specifically to rule out the alternative explanation. They took modern replica bronze, deliberately treated some samples with a chromate conversion coating. the way the original 1970s researchers had hypothesized the Qin dynasty might have done and left other samples untreated but placed in direct contact with chromium-rich lacquer, then ran both sets through accelerated aging chambers designed to simulate roughly 2,000 years of burial, in a fraction of the time. The chromate-coated samples behaved the way you'd expect a genuine anti-rust treatment to behave, forming a stable protective layer. The lacquer contact samples showed something different, a pattern of chromium distribution that matched what was actually observed on the real excavated weapons far more closely than the deliberately coated samples did, concentrated near points of former organic contact, uneven and consistent with passive chemical migration rather than a uniformly applied industrial process. That side-by-side experimental comparison is what allowed the team to state their conclusion as plainly as they did in the published paper. The chromium anti-rust treatment theory should be abandoned entirely, not just questioned. So if the chromium wasn't the reason these weapons survived so well, what actually was? The same research pointed to something far less exotic, but arguably more interesting: the soil itself. Laboratory testing comparing bronze samples buried in soil taken directly from the Xi'an site against bronze buried in ordinary British soil under identical accelerated aging conditions found a dramatic difference in preservation, with the Xi'an soil samples staying close to pristine while the comparison samples corroded heavily. The mausoleum soil at Xi'an is notably alkaline and extremely fine-grained, a combination that limits the oxygen infiltration and microbial activity that normally drive bronze corrosion underground. In other words, the secret preservation technology wasn't a chemical coating invented by Qin dynasty metallurgists at all. It was a geological accident of exactly where the emperor's tomb happened to be built, layered with sealed, low-oxygen burial conditions that modern researchers are still working to fully characterize. The corrected version of the story isn't smaller than the original myth. If anything, it reframes the entire mausoleum, complex as an unintentional 2,000-year preservation experiment, with chemistry the original builders never could have measured or planned for. There's a broader point worth drawing out of this whole thread of research, separate from the specific chemistry, because it says something about how these figures were built in the first place. The weapons weren't ceremonial props. Researchers cataloging the recovered bronzes found spears, lances, hooked blades, functional crossbow triggers, and an enormous quantity of arrowheads, as many as 40,000 recovered from the pits. So far, all manufactured to genuine military specifications, sharp and battle-ready, not the kind of symbolic decoration you'd expect if the entire army were purely ceremonial. That detail matters for how seriously to take the rest of the site's realism, including the question of the faces themselves, which is where the research turns next. Let's pull that together for a second. For 4 decades, a claim about ancient chrome, plating technology sat unchallenged in museum placards and documentaries worldwide. A large-scale scanning study, using instrumentation capable of testing hundreds of objects rather than a handful, traced the chromium to accidental lacquer contamination instead and pointed toward the true explanation, the specific chemistry of the burial soil itself. That's the kind of correction that real science is supposed to produce. Not a comfortable confirmation of an exciting story, but a more accurate, evidence-based one. Now here's a second thread of research, running alongside the metallurgy, that gets at an entirely different mystery, whether the thousands of individual soldiers were ever meant to represent real people. For decades, there were 2 competing theories about how the army's faces were actually produced. One held that the figures were assembled on something like an ancient production line, built from a limited set of standardized interchangeable parts, a stock selection of noses, mouths, and ears, mixed and matched across thousands of bodies, the same way a child might swap pieces on a Mr. Potato head toy. The other theory held that each soldier was individually modeled, potentially based on real people from the emperor's actual army. Settling that question required a feature specific enough that it couldn't plausibly be reused across figures by accident, and the research team landed on an unusual choice: ears. Forensic science has long used ear shape as a method of identifying individuals, precisely because the specific contours of the outer ear, the ridges, the curve of the helix, the shape of the lobe, vary enough between people to function almost like a fingerprint, distinct enough that a print left by an ear pressed against glass has been used as courtroom evidence in real criminal cases. Researchers built detailed 3D digital models of the left ears on a sample of 30 terracotta warriors, using photographic reconstruction techniques precise enough to capture the same fine ridges and contours forensic scientists rely on for human identification. When they ran statistical comparisons across that sample, the result was clear. No 2 ears matched. Every single one showed measurably distinct proportions and shapes, varying the same way a real, unrelated group of human ears would vary, rather than clustering around a small set of repeated templates. That result argues strongly against the mix-and-match assembly line theory at least for this feature, and supports the idea that individual sculptors were working from real observed variation rather than a limited standardized kit, whether that meant working directly from live models, from sketches, or from close memory of specific soldiers in the Emperor's forces. It's worth being precise about what this does and doesn't prove. It doesn't confirm a name-by-name catalog of real individual soldiers immortalized in clay. What it does confirm, at a statistically meaningful level, is that the ears weren't mass-produced from a small reusable set. Someone was deliberately introducing individual human variation into thousands of figures, a level of customization far beyond what a purely decorative symbolic army would have required. That result lines up with something researchers had already noticed just by looking at the figures directly, long before the ear shape data existed. The warriors show real variation across a whole cluster of features beyond ears alone. Broadly, researchers have identified around 8 distinct general face shapes across the army, from long and narrow to round and broad, further individualized with different hairstyles, headgear denoting different ranks, expressions ranging from stern to almost contemplative, and hand-finished details like eyebrows and facial hair added by sculptors after the main head shape had already been formed. That combination, a shared underlying production system layered with genuine hand finishing, is itself a kind of technical answer to a question that puzzled observers for years. How do you mass produce roughly 7,000 figures on a timeline of years or decades and still make every single one look different up close? The evidence increasingly points to a hybrid method, standardized at the structural level for efficiency, but deliberately, repeatedly customized by hand at the level of the face, essentially achieving something close to individualized production at a scale that would be labor-intensive even with modern tools, let alone with the workforce and technology available in the 3rd century BC. That individuality connects directly to a third layer of research, this one focused not on faces, but on where the clay itself actually came from and how the entire production operation was organized. Using portable X-ray fluorescence again, this time on the ceramic material of the figures rather than the bronze weapons, researchers identified distinct microgeochemical signatures in the clay paste. Subtle but consistent chemical differences that could be traced back to different source materials and, by extension, different production workshops. Some figures carry inscribed marks reading Gong, referring to the palace workshop, while others are marked Xianyang, the name of the Qin capital city. The chemical data lines up with those inscriptions, showing that these were genuinely 2 separate supply chains feeding raw material into different production centers, each apparently responsible for turning out its own share of the thousands of figures needed to fill the pits. That's not just an interesting footnote about pottery. It's direct physical evidence of the kind of centralized multi-site logistics and material sourcing operation it took to arm and populate an entire underground army at this scale. Coordinated supply lines, standardized inscriptions for accountability, and enough organizational infrastructure to track which workshop's raw material ended up in which finished figure over what was almost certainly a construction project spanning decades and drawing on hundreds of thousands of workers across the wider mausoleum complex. The clay findings also connect to a separate, ongoing thread of pigment research at the site, one that's easy to forget given how the army looks today. When first excavated, sections of individual figures still retain traces of their original paint, vivid reds, greens, and purples, applied over a lacquer base coat in colors and combinations that suggest a genuinely vibrant, almost theatrical original appearance, rather than the uniform earth-toned figures now on display. Most of that surface paint flaked and degraded within minutes of exposure to open air after 2,000 years underground, which is part of why so few visitors today realize the army was ever anything but plain clay-colored. Ongoing chemical and microscopic analysis of surviving pigment residue, combined with the same kind of non-destructive scanning used elsewhere at the site, has allowed researchers to identify specific compounds used in the original paint, including a synthetic pigment known as Chinese purple, a barium copper silicate that doesn't occur naturally and had to be deliberately manufactured, indicating a level of applied chemistry knowledge that went well beyond simply grinding up colored minerals. Newer excavation protocols now call for chemical stabilizing agents to be applied to freshly uncovered figures within moments of exposure, specifically to prevent the same catastrophic pigment loss that erased most of the color from the earliest excavated sections back in the 1970s. There's also a newer, ongoing piece of this story worth mentioning, because the scanning work at the site hasn't stopped. Researchers from Xi'an's Northwest University have continued using modern handheld 3D scanning equipment to digitally capture skeletal remains recovered from areas of the broader mausoleum complex, building detailed digital records of material that is often too fragile or too significant to handle repeatedly by hand. That kind of non-invasive digitization is quickly becoming standard practice across major heritage sites worldwide, precisely because it lets researchers study, measure, and compare fragile material in painstaking statistical detail, the same basic approach that cracked both the chromium myth and the ear shape question, without risking damage to objects that, in some cases, are the only surviving evidence of their kind. Now, the caveat section, because it's worth being honest about the edges of what's actually settled here versus what remains genuinely open. The ear shape study is compelling, but the published sample size so far has been relatively small, around 30 ears out of an estimated 13,000 or more across the full Army, and the research team themselves have been clear that this is an ongoing project, not a closed case. No confirmed correlation has yet been found between specific ear shapes and the artisan inscriptions marked on individual figures, meaning the exact production process, how directly sculptors worked from real people versus working from memory, training, or reference sketches, is still being worked out rather than fully resolved. Similarly, while the soil chemistry explanation for bronze preservation is well supported by direct comparative testing, researchers are still refining exactly which combination of soil properties matters most, and to what degree. It's also worth flagging that most of the more sensational claims circulating online about the mausoleum, rumors of elaborate mercury, booby traps, rivers of liquid mercury simulating real geography inside the unopened tomb chamber, or crossbow trigger defenses rigged to fire on intruders, come from a single historical account written more than a century after Qin Shi Huang's death by the Han Dynasty historian Sima Qian. And while soil testing around the tomb mound has genuinely found unusually high mercury concentrations consistent with part of that account, the tomb chamber itself remains formally unopened and unexcavated, which means several of the more dramatic specifics simply haven't been directly verified by anyone, ancient or modern. That last point is worth sitting with for a second, because it's easy to assume a site this famous has been fully explored. It hasn't. Chinese archaeological authorities have deliberately left the central burial chamber sealed, citing both respect for the site and the risk that current preservation technology still isn't advanced enough to protect whatever's inside once it's exposed to open air. Caution that, given what happened to the original paint on the warriors themselves, seems entirely justified rather than overly conservative. So here's where the real story actually lands, once you strip out both the exaggerated myths and the reflexive skepticism that sometimes follows a big correction. The chromium anti-rust legend, repeated in museums for 40 years, turned out to be an accidental byproduct of lacquer decoration once someone finally ran the numbers at scale, and the real explanation, sealed alkaline soil quietly doing the preservation work for 2,000 years, is arguably a more remarkable stroke of circumstance than the intentional technology it replaced. Meanwhile, the individuality visible in thousands of stone still faces appears to be exactly what it looks like. Not decoration, but a deliberate labor-intensive act of representing real human variation, backed up by the same kind of rigorous measurement that debunked the chrome plating myth in the first place. Two very different questions, both cracked open by the same basic idea. Stop repeating what sounds impressive and actually go measure it. So tell me down in the comments, which reveal changes your picture of the terracotta army more? The corrected story behind the bronze weapons, or the idea that somewhere in those three pits might be the closest thing we have to portraits of real soldiers who served under China's first emperor? Let me know what you think, and if these kinds of corrected evidence-first mysteries are your thing, there's more waiting for you right here.